All right, today we are going to talk about one of the most powerful forces on our entire planet. I'm talking about a force that literally moves continents and builds mountains. We're going to break down the incredible science of plate tectonics, the story of the very ground we're all standing on.
So, let me ask you this. Did you know that right now, as you're listening to this, the ground beneath your feet is actually moving? It's a pretty wild thought, isn't it? It feels completely solid, but it's actually on a super slow motion journey. So how on earth is that even possible?
Well, the answer is all wrapped up in this amazing scientific theory that completely changed how we understand our planet. The big idea is that the Earth's surface isn't just one solid piece, but it's more like a dynamic, constantly shifting puzzle.
And that big idea is called plate tectonics. Basically, it explains that the Earth's tough outer shell, the lithosphere, is broken up into these enormous plates. And these plates aren't just floating around randomly, they're gliding, really slowly, over a hotter, kind of gooey layer right below it.
So what are these giant puzzle pieces really? And what is it that lets them move around? To get that, we need to zoom in on two key layers of the Earth that make this whole thing work.
Yeah, pretty much all the action, all the drama of plate tectonics happens right at the boundary between these two specific layers. You've got the hard, brittle lithosphere on top, and then the hot, flowing asthenosphere just underneath it. And here you can really see the difference. The lithosphere, that's the hard outer shell we were talking about. That's the plate in plate tectonics. Right below it, you have the asthenosphere, which is this semi-molten, kind of tar-like layer. Because it's so much softer, it lets the rigid plates on top just glide along, kind of like giant rafts floating on a sea of incredibly thick, hot honey.
So how fast are we talking here? Well, on average, these plates move about 2 to 10 centimeters a year. Now, to put that in perspective for you, that's about the same speed your fingernails grow. So yeah, it's way too slow for us to feel day to day. But you give it millions of years, and that slow creep is powerful enough to completely change the face of the planet.
But what's actually driving all this? What's the engine powerful enough to push entire continents across the globe? Well, it turns out there's a massive, powerful engine running deep, deep below the surface.
It's really a combination of three main forces working together. First, you've got mantle convection. Think of it like a giant lava lamp or a conveyor belt, with hot rock rising and cooler rock sinking. Then there's ridge push, which is where new hot rock pushes plates apart. And finally, you have slab pull, where the cold, heavy edge of a plate sinks back down into the mantle and just pulls the rest of the plate along with it. And a lot of scientists now think that slab pull is actually the biggest driver of them all.
Okay, now we get to the really exciting part. All this slow and steady movement builds up an incredible amount of energy. And when these massive plates finally crash into each other at their edges or boundaries, well, the results are some of the most powerful and creative forces you can find on Earth.
And hey, this isn't just some abstract theory. The way these plates interact is the direct cause of the mountains we climb, the volcanoes that erupt, and the earthquakes that can shake entire cities. It's this constant, powerful process of creation and destruction happening all the time.
First up, you have divergent boundaries. This is where two plates are actually pulling away from each other. And as they separate, magma from down below rises up to fill the gap. It cools, it hardens, and it creates brand new crust. This is literally where the Earth is making new land for itself, mostly happening way down on the ocean floor.
Next, you've got convergent boundaries, and this is where the real power is unleashed. When two plates move towards each other, one of two things usually happens. Either one plate gets forced down under the other, that's called subduction, and it often creates volcanoes, or they both just crumple and push upwards, forming absolutely massive mountain ranges like the Himalayas.
And finally, we have transform boundaries. Now here, plates aren't colliding or separating. Instead, they're just sliding horizontally past one another. They grind and catch against each other, building up a huge amount of friction and stress. And when that stress is suddenly released, bam, the ground shakes violently. This is what causes a lot of the world's most famous earthquakes, like the ones you hear about along the San Andreas Fault.
So when you zoom all the way out and think about all these forces working over millions and millions of years, you start to see that our planet is just incredibly dynamic. The world map that we all know so well, it's not permanent. It's really just a single frame in a very, very long movie.
And you can see the result of all that movement right here. About 250 million years ago, pretty much all the land on Earth was smashed together in one giant supercontinent we call Pangaea. Over eons, plate tectonics broke it all apart, and the pieces drifted to form the 7 continents we have today. It's amazing to think that our world map is just a snapshot in time.
So the takeaway here is that our planet is alive. It's not just some static rock floating in space. It's a world that is in constant motion, building mountains, carving out oceans, and rearranging entire continents. You could almost say plate tectonics is the fundamental operating system for our planet's surface.
And that leaves us with a really fascinating thought to end on. This whole process, it hasn't stopped. It's happening right now. So based on everything we've just talked about, what do you think our world is going to look like millions of years from now? Definitely something to think about, right? The ever-changing ground right beneath our feet.